Okay, solving inequalities is when you have either a less than, greater than, less than or equal to, or greater than or equal to. So there are 4 different inequalities, okay? Not just one, there are 4. You have to be able to read those. I always look at it this way. This is how I read it. It always points to the smaller. So this one's greater and this one's less. This one is less, that one's greater, because a little point goes to the smaller one. Now that's how I remember it. I know there's the alligator. The alligator eats the bigger one, okay? You can use that too. I don't care how you remember, just have a way of remembering what that stands for, okay? In these, when we get them, we get a range of numbers. That means that there's going to be a whole bunch of numbers. It's going to be a range of them. It could be 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, all the way up forever. Or it could just be the numbers 0 to 2. So it would be that range of numbers, though, everything between 0 and 2. Okay. So we have done some things. We've graphed with inequalities up to this point. So I'm going to just really quickly review how you graph inequalities. So when you're graphing an inequality, basically, if you have just these signs, okay, you will put an open dot on the number line. Okay. If you have these, then you put a closed dot on the number line. Excuse me. So an example, x is greater than 3. This is greater than 3 is smaller. So here's my number line. I'm very picky. 3 is your boundary, okay? 3 is the number I got to be greater than. So it says x is greater than 3. It does not include 3 because 3 is not greater than 3. This is not a true statement. That is untrue. Since it's not true, you put an open dot on the 3, okay? And then you would shade where they're larger. So since 4 is greater than 3, we shade this direction. 5 is greater than 3, 6 is greater than 3, so we shade towards the direction of the answers. Now we can't give all the answers. We can give a sample of answers, but numbers that are greater than 3 could be 3 1/2. It could be 4 1/2. It could be 3 1/3. It could be 3.1. It could be 3.000000001 because that's still bigger than 3. It's really close to 3, but it's bigger. So we can't actually list all the numbers because there's an infinite amount. In these, there's always an infinite number of solutions. Okay, if you have something like this, oops, I don't want to go that way. Okay, so that's called a compound inequality. It gives you the smallest value of x and the largest value of x, so it's called compound. Okay, so in that, my 2 points I'm going to put on my graph are these: 3, 4, 5. As long as you're consistent, make it kind of consistent there, okay? So I know it's somewhere between 3 and 5. At least that's what this says. It says 3 is less than x. So x has to be greater than 3. That's because 3 is less than x. But since it's less than and it doesn't include that, we put an open dot. it says it's smaller than 5 or equal to 5. So this one, x equals 5, is a true statement. So I put a closed dot on 5 because it includes 5 as an answer. Okay? The numbers that are between 3 and 5 are all these numbers in there. Is there an infinite number of numbers between 3 and 5?
Yes.
How do you know?
Because of all the decimals.
All the decimals, all the fractions. We can always cut it in half. That's kind of a mind-boggling thing. You can always get it smaller by cutting them in half, cutting them in half, cutting them in half. And so you get a smaller, 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 but our pencils don't draw that small, so we actually can't see all those little tiny points. And you would never see all those little tiny points, but because we draw things and write things, and in all practicality, it gets so small that you are going from one to the next, okay? So we know there's an infinite amount, but we cannot comprehend that. It's kind of like this. Grayson, stand up. Oh, I like to pick on you today. He's not in trouble. Okay, come halfway to me. Okay, come halfway again. Come halfway again. If he continues to go halfway to me, does he ever run into me? Technically, he wouldn't. But for all practical purposes, he will. You know why? Because he has width and depth and height. He is an object. Okay, it's only if we go really, really, we get close, but actually in theory, we never could touch. But that's imagining that we are a point which has no, it's infinitely small too. We don't, we're bigger. We're gonna practically touch, okay?
Our
So
electrons
those are some,
are gonna touch.
those are what?
Our electrons might not touch, but we're
Correct. Our electrons may not touch, but our bodies are gonna touch that are made up of those electrons, okay? And so this is kind of an interesting thing, the infinite betweenness. It's called, there's an infinite amount of points between these two lines, between 3 and 5. It's an infinite number of those, and that's very hard to comprehend. I do think it's one of those mysteries that God lets us ponder, okay? It's one of those that it's a thing that works, it's true, we know it theoretically, but in practicality it doesn't. So how does that relate to the universe? I don't know. It's kind of interesting. Okay, so what we're going to look at now, we've kind of reviewed all the things that we do. Again, we're going to solve our equations. That's our goal. But before we do that, we have to practice something. Okay? We have to learn how inequalities are different than equations. They're actually very similar to equations, but there's one thing that's different. So how are inequalities different than equations when multiplying? Well, when multiplying or dividing, they would be, because dividing is the same. Okay, I'll just tell you, they're same in everything except for this area. They are different in multiplying and dividing inequalities. So we're going to look at a couple things. So if I have 2 is less than 6. Does everybody agree that that's true?
Yep.
Okay. So in equations, we can multiply both sides of the equation, now we're doing the inequality, by a number. Okay, let's see if the equation is the same. Let's see. if I multiplied all of this by 3, so I'm going to multiply this by 3, this by 3, doing the same thing on both sides, I get 6 is less than 18. Is that still true?
Yeah.
Okay, so that is still equivalent. You're still getting an equivalent expression. Okay. What if I have 2 is less than 6, and I multiply it by a negative 3? Okay, so here I multiplied it by a positive 3. Okay. Negative 3 times 2 is negative 6 is less than negative 18. Is that still true?
No.
No, that's not true. Okay, so it looks like if we multiply by a negative, the inequality is not true. Okay. Could I write that a different way to make it true? How would I write it?
You switch sides.
You switch the side, well, you switch sides, or you switch the sign. The sign's actually easier to switch, okay? So we get, this is a true statement. Is that not correct? Negative 18 comes farther to the right than negative 6 comes farther to the right than negative 18. That's how we know it's greater than. Because on our number line, negative 18 will be out here, negative 6 will be here, so that is a greater number. Okay, so you have to think backwards with negatives. Okay? That's why you have to switch it, the sign. That makes a true statement. Let's see if that's always true. Do you think if I always do it by a negative number, it will be not true and we have to switch? That's our next question. Okay, so let's look at 1 is less than 5. Okay, I want to multiply each side by negative 2. Let's see, we get negative 2 is less than negative 10. Is that true? Not true. Is it true if I switch the sign and make it negative 2 is greater than negative 10? Is that true? That is true. Okay, so we switched the sign to make it true. Okay. So that's the thing we have to do. We have to be able to switch the sign. This is the difference. When we multiply, so we come up with this general rule, is when we multiply or divide by a negative number, we have to switch the direction of the inequality to make the statement true. Okay. That is the only difference between solving an inequality and solving an equation. Everything else remains the same. Okay. This is the only thing that's different, and it's one of those things you have to remember to do. But other than that, we solve inequality statements just like equations. But if we multiply or divide by a negative number, we have to switch the sign. So this is the big, important memory thing when we're dealing with inequalities and solving them. Okay. So section 3.7 goes into practice of these and just takes this into account. So we start solving inequalities. So we're going to start looking at that. Okay, so if I'm solving an inequality statement, we use the same process as solving an equation, whoops, except if we multiply or divide, oops, both sides of the inequality by a negative number, we must switch the sign, the direction of the inequality. That's a lot of words, okay? That's a lot of words. Really comes down to this. So let's look at an inequality. Okay, so this is what we have. We're solving it. We're going to use the same process as an equation, except for if we at some point multiply or divide by a negative number, not add or subtract, not subtract a negative number, but just multiply or divide by a negative number, then we have to switch those signs. That's the only thing that's different. So what would be my first step here? Mason, what would I do first to solve this equation? This inequality.
The same thing you would do for everything else.
Yeah, so what would I do first?
-5,
I would -5 on both sides. When I'm minusing 5, I'm not multiplying or dividing by 5, am I? Okay, so that's not what we're worried about. So that's going to cancel. So we have -2x still greater than or equal. And I always recommend keep that greater than or equal coming down with you as you're doing it. This is 2. Okay, because 7 minus 5 is 2. Okay, what would be the next thing I'm going to do, Matt?
We would divide both sides by -2.
Oh, we're going to divide by what?
-2.
We're going to divide by a -2?
Yeah.
Oh, that should send off alarms because I'm doing an inequality.
Wow.
And I need to remember that when I divide or multiply by a -2, it switches signs. So I'm going to divide by a -2, divide by a -2, but as I come down, I have to switch that sign because I am dividing by a negative. Dividing by a negative, switch signs. So this becomes 1x, but instead of greater than, it's less than or equal to -1. Okay, so when we divide by that -2, it causes this, and I like to just put that little arrow there to show I'm switching the signs. That reminds me. And then I just do the division, and so x is equal to, not equal to, it's less than or equal to -1. Okay, it can be -1. What other numbers could it be? Yeah.
Negative.
-3.
-3. Another one, Brill. -4. Matt.
-1,554.
That's correct. -1,000, whatever you said.
2 seconds of thought.
That's what I know you did. Okay, so that's what happens. That's the only difference when you're solving. But I always say, when I'm doing this, think if I say I'm going to divide by a negative, alarm should go off in my brain saying, we have got to switch the sign. Okay, now let's check a multiplication one. This is when you would multiply by a negative number. So let's say we have -3/5 x is less than or equal to 5. Okay. How do I make the number in front of x equal 1? What do I multiply by? Yeah,
Sorry.
you're right. Let's go.
No. You raised your hand. You raised your hand.
Go ahead.
5/3.
Is it going to be positive or is it going to be negative?
I believe negative.
Negative, because we need to make it a positive 1. Okay, we have to make that a positive 1 in front of x. So to make this a 1, I'm going to multiply by its reciprocal, 5/3. Negative 5/3. Okay. Multiplying by a negative number. Okay. So I have to switch. That becomes 1x greater than or equal to 5 times this is going to be -25/3. Make sure you know how to do that. That's 5/1. -25/3 would be your answer. But we switched the sign, so x is going to be greater than that. Okay, so those are the things we're looking at in this section. Okay. Questions on that so far? That's really what 3.5 and 3.6 are all about. Or is it 3.6 and 3.7?
3/6 and 3/7.
Sorry, it's 3.6 and 3.7. I lied to you. Got the wrong ones up there.
Why would you lie to us?
Because that's,
Small sinners.
I have no